First of all, yes, the H and the L stand for hypotenuse and leg. And as I was saying previously, this is, gentlemen, this is our last shortcut for how we prove two triangles congruent. Let's put the phones away. We are taking notes. The hypotenuse leg theorem says that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then what do you know about the two triangles? They're congruent, yes. So one point that I want to stress is that even though HL theorem only has two letters, I don't want you to perceive that as just two things that you need to know. You still need to know three pieces of information. It's just that now that third piece of information isn't a congruence statement, it's the fact that you're dealing with right triangles. So be prepared in your proofs to see the statement or to make the statement that you have right triangles because of the definition of right triangles. What is the definition of right triangles?
We never heard about
having one right.
Yeah, we got that in yesterday's notes.
Yeah, it's one of the right. Yeah, one right.
Caroline, did you?
Yeah, yeah.
And I will once again have some click and drag action going on with our proofs today. A couple of things that I heard that I want to kind of make a point about. As the vocabulary was getting dragged into place, one of the things that I heard is the hypotenuse is the longest side, right? And yes, that is absolutely correct, even though that's not the definition of the hypotenuse. That is an important point. The definition of hypotenuse is it's just the side opposite the right angle. But yes, it is an important trait of the hypotenuse that it is the longest side. And we're still getting what we need from this screen? So, who wants to come up and click and drag for our first proof? Benjamin. Oh, hold on. Okay, go.
Oh, hit the wrong one.
Okay. Someone else? What else do I need in my proof?
Are you okay?
What else do I need in my proof? Hope. Excellent. What else do we need? What else do we need in our proof? Don't lose track of the fact that we're trying to prove two triangles congruent. Go ahead, Caitlin. So far I've got 2 pieces of congruence information. What else can I put in here? Remember, just because our new theorem only has 2 letters doesn't mean that I just need 2 pieces of information. Hypotenuse and a leg exist in what kind of triangle? A right triangle. Have I identified these triangles as right triangles?
Yes.
Not yet. We said that we have right angles.
Oh, I know.
Benjamin, go ahead.
Can't look at me.
Excellent. And then, of course, ladies and gentlemen, you always know where you start, and you should always know where you're finishing. Caitlin, go ahead and finish it off. Say that again, please, Benjamin. It is hypotenuse leg. Realize why it's not side angle side. If I mark PR, notice that the angle that's marked in that triangle isn't between the 2 sides that are marked. This isn't side angle side, it's hypotenuse leg. Be very careful. On to our next click and drag proof. Who'll start me out here? Go. Okay, someone else. What else do I need in this proof? I decided to, kind of force the issue and demand a little fun. Caffeine hit this morning. So what else? What else do I need in this proof? No, we do not need yo mama in this proof. That's just my little, silly attempt at humor. Yes, Hope. I'm sorry? Oh yeah, she was just up there, wasn't she? Someone else, please. What's next? Uh-huh. I'd like someone else to be on a roll. What else can I say in this proof? What else do I need to say in this proof? Look at what we're given. Ask yourself, what can I do with that? What do those words mean? if segment AD is the perpendicular bisector of segment CE, what does that mean? What does that allow me to say? Hope's on fire, but I'd love to see someone else come up. Be bold, be brave. You probably know exactly what you're doing. Show us what you got. Remember that I've mentioned this before. If I say that something is Benjamin?
What is? Shouldn't we see segment CD's congruent to EA definition of perpendicular?
No, segment CD is congruent to EA because that's given to us.
I don't really. Oh,
Never mind. What can I do? Catherine, please. End our stalemate here. Good. Good. Remember, the term perpendicular bisect has two words in it. Perpendicular, we haven't used that yet, and bisect, which is what Catherine just did. Michael, you have the next statement? Okay. We haven't used the perpendicular part of that given yet.
Oh, I see.
What does that allow me to say? Huh?
We know what it is.
Go on. Be bold. Be brave.
I'm not bold and brave.
Okay. How about if someone else is clicking and dragging and you're just telling them what to do? Caitlin, go ahead. Teamwork. Fantastic. What is the definition of perpendicular? Daria. Perpendicular lines intersect to form right angles. So the definition of perpendicular has to do with what? Segments, or allows me to conclude something about what? Segments or angles? Angles. So I am going to use the definition of perpendicular, but I'm not going to use it to say that.
It's the angle.
Daria, fix it, please. Well, the definition of perpendicular lines says that I have right angles. There we go. I can say that I have right angles in these triangles, and thereafter, what can I say? Issa, tell me again that vocabulary that we learned yesterday, that I mentioned today that you said we didn't actually learn yesterday.
Right angle.
Oh, what has a right angle?
Right triangles.
Right triangles. Issa, you want to click and drag that into place?
Where is it?
It's somewhere up there.
Definition of right triangles?
That's going to be my reason, yes.
I don't know the rest.
Well, what we're saying is that these triangles are right triangles.
Oh, pick me.
Pick me, pick me. Go ahead, Caitlin, finish it off. We now have enough information to say that the triangles are congruent.
You're scaring me.
Have that effect on people. No, not because Clouse said so. That won't work on the EOC. There we go. Because of the hypotenuse leg theorem. Okay, so we're continuing. Can I get a volunteer to start filling in the statements and reasons for the your turn on problem 2? Caitlin, go ahead. While she's doing that, hopefully you noticed that the your turn in problem 1 was a very, very straightforward yes or no question. So are those triangles congruent in the your turn for problem 1?
Am I filling out all of it?
Yeah, go ahead. You might want to grab your notes.
I got this. Don't worry.
Hypotenuse, leg.
Yeah, the triangles are congruent because of hypotenuse leg. Pretty straightforward. And while she's using that, I'll be activating a daily quiz on Socratic.
Bubbles, I have to show you something. Okay.
He's a golfer.
Yes.
Yeah.
Bubbles, It's taking forever.
And there is a daily quiz activated on Socratic. I think the first diagram is cut off though. So you'll get to typing in your name and then you'll look at question 1 and it's not going to make any sense because for some reason the diagram isn't there. I'll put that up as soon as Caitlin's done. Huh? Okay, I'll put that on the screen. Thank you. Okay, so you'll notice in this particular proof that the structure was given to you and you were just filling in the blanks, and there was something missing in this proof. What was missing, Michael?
Saying that AC was equal to AC.
No, I mean like once the proof is completed, there's something missing in this proof that we made sure to have in our other proofs, the click and drag proofs. The statement that the triangles are in fact right triangles. And you'll notice that sometimes in these fill-in-the-blank proofs that are in your book and sometimes even on your assessments, they may skip a step like that. You just need to be able to adapt and fill in based on what's there. Okay? So, there is supposed to be a diagram for